Hello everyone, and welcome to our second lecture giving an introduction to software testing, or more specifically testing in terms of systematic testing. So these are methods that are more systematic in nature. There are types of testing, as I mentioned last time, such as exploratory testing, where it isn't quite as systematic, but what we're going to focus on first is the more systematic methods. So last time what we did was we covered some of the basic definitions. We described what we mean when we use the terms validation and verification. We also discussed how testing and debugging are related but actually refer to distinct things. We also talked about the different levels of testing, so mainly talking about unit testing, integration testing, system testing, acceptance testing, and also talked about how with unit, integration, system testing, they're actually related to different levels or different types of specifications. So in unit testing, you're addressing detailed design specs. In integration testing, you're dealing with higher level design details and specifications. And in system testing, you're dealing with requirements specifications. So that's the things we covered. What I want to, and we also talked about test-driven development. What I want to do today is continue with this by talking about testing in the life cycle, talking about some specific activities that involve testing, namely testing, design, and strategy, test plans and procedures, and test results. And then I want to discuss two broad categories of test methods that you'll often hear discussed, namely black box testing and white box testing. So let's, in terms of the kinds of testing and testing in the life cycle, testing actually has a role to play in almost every stage of software. Now, I use the term stage here for the general stages of activities that you do. Obviously, depending on if you're using an agile method, if you're using a more traditional method, incremental development, whatever it is, the phases of your development cycle are going to be different, but they're largely all going to include the same activities. You're going to at some point have to do design. At some point, you're going to have to do implementation, etc. So normally, what the types of testing we do, and we talked about last time, they fall into different points in development. The unit tests are often used right when you're developing the code, right at the beginning. And once you sort of get units being integrated into subsystems, that's when you include integration testing. And then later, when you actually get a complete software system, or at least a complete version of the software to release, that's when you want to do acceptance testing, and that's also when you want to do system testing. And in terms of testing in the life cycle, we divide the tests that we do into two types of general categories. One of them that we talk about is what's called black box test methods, and the other one is white box, or glass box is another way of doing it. The real big difference here, you've heard probably more generally the term a black box. A black box is when you're talking about some system that you don't understand what's going on inside. You have no knowledge of the internal workings. You just know and understand it from its inputs and outputs, right? So how you interact with it. So it's a black box. That is actually one of the approaches for testing. And in a black box method, when they say it's black box, it means that you have no knowledge about the source code that's internal to it. And namely because it may not even exist yet, right? With black box testing, you can base the tests entirely off the requirements and the specs. Think system testing. And you can do that independent of how the software is implemented. So if you assume the software is a black box in terms of how it's coded, you can create your test based on the requirements and then test the software after you build it against those black box tests. Now, white box tests, on the other hand, or white box methods, those are types of testing where you can rely on insight into how the software is implemented to help you do your testing. Namely, you can see the code, and if you know how the code is worked, you can actually base your tests on that code, or even what we call gray box testing, where you have a partial view, where you use the architecture or the design of the software to base your tests. An example of this would be unit testing, right? Unit testing is typically a white box method. So say, for example, you're testing an individual function. That function has inputs. What are the inputs of a function? Things like the parameters it takes in, as well as any global variables it reads, that kind of thing. And it has outputs, such as the return type and any global variables again. So those are your inputs and outputs. And what you could do is you could design tests so that every if statement gets executed as true or false. And in order to do that and create those tests, you have to know about the source code in that function to be able to know where all the if statements are and be able to know what inputs you need to provide to cause each if statement to be evaluated both true and false. So that just gives you a little bit of insight into how black box versus white box works. An obvious question here to ask is, what's better? Should I base my tests on the requirements independent of source code, or base them on the source code where you have more knowledge about the implementation? And the answer is that which type of method you use, often there's context around it. And the reality is that some combination of them is often the best, because white box test methods and black box methods, they can actually find different kinds of errors. So for example, white box testing is typically, it will find what we call errors of commission. Those are errors in terms of how you've done something, how you've implemented. Whereas black box, because it's based on the requirements, it can actually find what we call errors of omission, where you maybe haven't fully implemented a feature. The black box test, which is based on the requirements, can find out about that missing feature, whereas your white box test would never find out that a feature is missing. So they both have value, they both can be used together, and it really comes with experience as to which method you want to use when in the development lifecycle. The key here, though, is that testing should be something that is a priority that's used throughout. Okay, so speaking of when testing is used in the lifecycle, it's also important to talk about testing after deployment, meaning after you've developed and released the first version of your software, when you're continually maintaining it, maybe for years, there is testing involved in that. And the way we test software that's being maintained or is evolving through new features being added, bugs being fixed, optimizations happening, and so on, maybe porting to new platforms, all that kind of stuff. What we typically would do in this is we would use what's called regression testing. And the idea here is that with regression testing, we are actually going to look at maintaining a set of regression tests which ensure that the current behavior of the software, the existing behavior, isn't broken. So once we release it and we've done all our testing, hopefully the tests have all passed and we have a certain understanding about what works and what doesn't work, or we know that things work. As we go and modify and extend our software through maintenance, we don't want features that were working at the beginning of when we released it to all of a sudden break. So we want a way of sort of verifying that the outputs we've achieved in past versions of the software actually still work. So that is what regression tests are about. It's about ensuring that we, when we make a change, a bug fix, a feature enhancement, or whatever, that the existing behavior doesn't actually get broken. Now, there's also another type of test. So that's what we call regression tests. There's another type of test that we also are interested in during maintenance, and those are called failure tests. So as the software fails, because inevitably your software is never going to work perfectly all the time. So as you discover and fix failures, it's important to maintain a set of what we call failure tests. And what we're trying to do here is, while regression tests are trying to ensure that good behavior that worked in the past still works, failure tests are trying to ensure that failures we've observed in the past don't come back. Okay, so if we have a test that caused a failure and then we fix the failure and that test works, we keep that test around to make sure that in the future that failure doesn't happen again, right? It doesn't reappear. So this is another type of test that we're interested in. mainly during software maintenance. Another thing to think about, so that's about testing in the life cycle. Now, like I said, testing is used throughout. So we've talked about different types of testing, a lot of black box, white box, unit integration system testing that happened during the active development. We've talked about the use of regression tests and failure tests during maintenance of the software. You can even, I didn't talk about it, but you can even actually do things like test your design. So depending on the method you use, for example, if you use in your design, you use something like UML, so you did a more formal design, you can actually talk about executing or simulating UML design models as a way to test them to make sure the design meets the requirements before you implement it as source code, which is kind of a cool idea as well. So regardless though of what type of testing you're doing and when in the development lifecycle you're doing testing, it's important to understand some of the primary activities involved with testing. And that's really what we're talking about, is the design of tests. And test design stages, so just like with software development where we have different phases and we have a process for developing software, we also have a process for testing. And that usually involves 4 activities. The first one is what we call test strategy, which is the high level. We then have test planning, test case design, and test procedure. So that's what we're really talking about, because often the design of tests, it's actually a fairly involved engineering problem that we have to work out. And it really does, it is important that we think about testing not just at a low level of when we create tests, but think about it from like the high level strategy of why we're testing, how we want to ensure quality with tests, all the way down to how we actually execute tests that we've designed, get the results, and verify if the results are correct or not. So it's really important to think about testing from both a high right down to the low level. Okay, so at the high level, the first thing we do is we have to have a test strategy. So a test strategy can be thought of as a statement of the overall approach to testing for an organization or a particular development team. So what does a strategy include? A strategy includes your overall approach to testing. What levels of testing are you going to be doing? What methods are you planning on using? What techniques? What tools? What infrastructure exists that will support your testing? So it is really an overall strategy for how testing will be used throughout the development lifecycle to ensure quality. Because its goal is about ensuring quality and providing confidence in the software, the test strategy usually is part of what we call an overall quality plan. And this is something that has to be followed and reported to all members of the project. And if you're going through, which we haven't talked about in the course yet, but if your course, for example, if your project or your organization is actually wants to be certified by different standards, they often will have to maintain documentation on things like the quality plan as a means of demonstrating that they actually have a quality process. So, what is an example of a strategy for testing? Well, one strategy, and these are really high-level strategies. A real strategy description will include a lot more detail in this, but I just want to give you a general idea. One way of thinking about testing as a strategy is to think about what we call Big Bang testing, right? And this is something that was often much more appealing when software was smaller, or when dealing with smaller systems in general that were a lot easier to test and had a lot fewer requirements, a lot less code. And in a Big Bang testing strategy, the idea is that you code everything, you write it, and then you test it all at once, right? So when do you test? When you're done the code, then you test everything completely. What we've learned though is that isn't actually, like when you're dealing with larger, more complex systems, a Big Bang test strategy is not the most effective way to test. Namely because if you wait till the end in a large complex system and you find a bug, you now have to go through the entire code base of that large system to find what caused that bug, right? What caused that erroneous output? So a better strategy, I would argue, is to take a more of an incremental testing approach or testing strategy. And that's one where you test in phases. So you test units, then you put them together and test them as components or subsystems in integration testing, and then you test the entire thing at the system level, but only after every component and every unit has been tested and all the subsystems have been integrated and tested. So the bugs then that you find at the system level aren't going to be, are going to be things that are more relevant to the overall requirements and less likely to be small coding mistakes that could be picked up with unit testing, that kind of thing. So this is the strategy that we typically use, this idea of incremental testing. That's what we often will use in more agile development methods, right? So we're going to be doing our unit testing, like for example in Scrum, as you're developing and you're implementing from your sprint backlog different stories. You're going to be, as you implement the code, you're going to be doing things like unit testing, and then you're going to be getting towards integration testing of when you add those implementations in with the existing system you have, doing integration and system testing. So it's typical that that type of testing strategy is going to be used in an agile development shop. There's a couple things that also should be mentioned is incremental testing can also occur bottom up or top down. Bottom-up testing is when you use drivers to sort of test each individual unit. So an example of this would be where you create a bunch of functions or methods that do different things, and you test each of them by writing code to do them. That's often how something like JUnit will work. You can think of the JUnit test as essentially a driver for that piece of code. Another way to do it is what we call top-down testing, where what I'm going to do instead is, let's say I've got a system that, a banking system. I'm going to implement the main sort of driver code first, and I'll be testing that. And what I'll do is that the parts of the system that are missing, right? Maybe I haven't implemented how to do withdrawals, or I haven't implemented how to do transfers or whatever. I put stubs in for those, meaning I put little placeholder functions that don't really do anything. They just provide back a typical value, and we'll build them in later, and then we'll test again. So you sort of increment by adding in and filling in the gaps of the stubs in top down versus bottom up using drivers to test pieces and then putting them together after. So in general, bottom up is easier, which is often why it's used, but it does have the side effect of you don't get to observe the overall system behavior till later. So it means that system testing comes later, but you do benefit from the fact that everything in the system has been tested independently as units. Okay, so that's a little bit about Big Bang versus incremental. The very last thing I should mention is that in general, incremental is used in things like Agile because of several reasons, and I already sort of said this: error identification and error correction. Easier to identify more errors in incremental. Okay? Mainly, if you think about it, it makes sense. I'm testing at multiple levels versus a single level at the end. Probably going to find more errors by doing that strategy because I've got multiple types of testing happening. Error correction is also easier in incremental because it's simpler and requires less resources. Errors that I find in the unit testing, if the unit's only 100 lines of code, I only have to look through 100 lines of code to find where the bug is. So because I do the smaller up to the larger, I'm going to find a lot of errors sooner and require me to look through less code. Whereas if I do it all in one big bang at the system level, and say that system has 1 million lines of code, every test that fails, I have to look through 1 million lines of code potentially to find the bug, which is going to be much more costly. So those are the reasons why really you want to use incremental, and why that's what we'll be doing in the course. So that's about test strategies. Any questions about test strategies? And like I said, I just gave 2 broad examples. So for the course here, you'll be doing an incremental test strategy, and in terms of the tools and stuff you use, that's something we'll be discussing. Once you have a strategy, the next thing you want to do is you want to have to come up with a plan. And the test plan is really is how you're going to realize the strategy in a given project. Okay, your strategy for testing could be your organizational strategy or your team strategy that applies to multiple projects. The test plan is really project specific and says, how are we going to achieve this strategy in this project? What it includes is things like what items will be tested, what is the level for all of these items, right? What are the different units that are going to be tested with unit testing? When are we going to do integration testing? What about the system testing? It'll also talk about the order of testing. It'll include more concrete details about the test environment, and so on. And while you may have an entire single plan for your system, for your whole project, it also might be, and especially in very large system development or in distributed development scenarios where you have a team, for example, in one office developing one part of a product, a team in another part of the world, even at another office developing another part of the product, they might have separate plans for testing their parts and then a plan for testing at the system level when they get integrated together. So it just really depends. But the test plan is sort of the realization of how the test strategy will actually be applied in the current project. Now, once we have our test plan in place, the thing we haven't actually done is we haven't created any tests. So test case design is sort of the next thing we have to think about. And this is really important because it's the test cases, the quality of the tests, whether or not the tests provide the coverage and evaluate what you want them to. They're really important because the tests are what provide a lot of the confidence in your software working correctly. So what you do at the test case design phase is you actually need to specify the test cases for every item that's being tested at every level. So that means for every single unit that you test, you're going to have to go through the process of creating tests. For every integration you're going to be testing, you have to go through the process of creating integration tests. For the system, when you do system testing, you need to have a set of system tests. When you get into regression testing during maintenance, you need to know what are my regression tests, what are my failure tests, and that I'm going to be using. So this is sort of what you do. You have to create tests for all levels and all items that are being tested, that are under test. And each of these test cases is going to specify how the implementation of a particular requirement or design unit will be tested and how you will know if the test is successful. Okay? So what that means is knowing if a test is successful. When is a test successful? Yeah, if there's no errors is one example. Or when the code does what we want it to, when it produces expected output. All those are good answers. So, a successful test is one where the output from the test is what was expected, which usually means it doesn't have any errors, and also usually means does what you want it to. And the tests that you create and design typically include a couple different categories. And one way to think about tests is to think about both positive tests and negative tests. So this is important to know, is that the positive tests are your testing that the software does what it should, right? If this software, like our example we're doing in our project, we're doing the short-term rental, right? So I'm going to want, if one of my functions is about renting a property, I want to know that when I actually request to rent a property that's available for a certain number of nights at a certain rate, that I'm charged the right amount. I also want to make sure that I actually rent the room. Or rent the place. So that's an example of a positive test. Whereas you also may want to have negative tests, which test that it doesn't do what it shouldn't, right? So you may, for example, want to have a test that ensures, that a credit card isn't overcharged. Or you might want to have a test which ensures that when a booking is canceled, it doesn't delete the book. It doesn't delete the listing for the property. Or there's different things you could do, right? Or maybe you want to test, in terms of security, you want to test that that it's the case that I can't access listings that I didn't create. So I can't go in and access somebody else's properties in the system. And then you also are going to be doing your test case design separately at every level. So you're going to have different tests at the unit level than you have at the integration level, the system, and the acceptance. And every one of these tests is going to also be documented with a purpose and a name. And the details about all your tests, they form what we call the test spec. So just like you have software specifications, you also have test specifications. And why is it important that you have test specifications? One of the reasons it's important is because, as we learned last time, tests don't die. Tests stick around, and you have to maintain them. So in order to maintain them, you have to have an understanding of why the tests are there and what purpose they serve, so that you can know when they can be decommissioned, when they should be modified, and so on. If you don't have any details about the tests, how can somebody know how to maintain them? So after test case design, once I've created all my tests for my software, or you've created all the tests for your software, the final stage is what we call the test procedure. And this is the process for actually conducting the tests. And what does conducting tests mean? It means that you're running and evaluating the tests. And this has to be done at every level of testing again. So that means at the unit level, you need to have a method for running and evaluating your tests. This can involve a whole bunch of things. It can involve what we call test harnesses, writing programs that execute tests. It could involve creating automated test scripts. We're going to be doing that in one phase in this project, automated scripts to run all of our system level black box tests. Or it could be a commercial testing tool like something like JUnit, which allows you to automatically run a whole bunch of JUnit tests that you write. So the test procedure is the process of actually running the tests, recording the results, and evaluating them against the expected results. So in terms of documenting the test results, when we execute the test, we should have some way of recording what all the results of the tests are. So essentially you want to have a log that actually, if I want to go back and see what was actually the output, I know that test failed, but why did it fail? What happened? There should be a full log of all of the inputs and outputs to the system so that I can go back and look at any individual test and see exactly what happened. So that's sort of what we call a results file. We also should have some sort of summary, a readable report. So this is a report that doesn't include all of the raw data in terms of the outputs of tests and so on, but includes a report of all the tests that passed, all the tests that failed. The report is sort of the high-level overview that should be concise, that we can clearly see where the failures are and where the unexpected changes are. To better understand those failures and unexpected changes, we then can dive deep into the results file as needed. Another thing to keep in mind is that the results file should be standardized because we may later on want to compare it with future test executions. So I might want to see all the tests run against two different systems or two different versions of my system and see how the results were different. Okay? And we'll see why that's the case a little later in the course when we talk about regression testing. Just to recap here a little bit, what I've talked about today is I've talked about the importance with testing of having a test strategy, a test plan, a test case design, and test procedures. And those are sort of the main steps. But what I haven't really done is said specifically to you what exactly is systematic methods in detail. So I just want to reiterate, I may have mentioned it in the last class, I don't recall, but a systematic test method. So what makes a test method systematic versus, say, ad hoc is that the test method needs to have a system for creating the test. So it needs to have a clear approach to how you create the tests. It can't be I just randomly generate them. That's not systematic. That's just random. It also has to have a measure of completeness. So you have to have a way of knowing when you're done. Example that I used earlier was I talked about with white box testing. Let's test that all the if statements evaluate the true and evaluate the false. Okay? So what would be, in that case, what would be my system for creating the test? My system would be that for every if statement, I create an input that causes that if statement to evaluate the true, and I create an input that causes that if statement to evaluate the false. And I do that for all my tests, or for all my if statements. That's my system. My measure of completeness is when I look at all my tests, and I've created a test for 2 tests for every if statement, one that's true and one that's false. Evaluates the true and false. That's when I'm done. So that's a systematic approach to what we call to something like branch coverage, where we evaluate all branches to true and false. Now, when you're doing this, and remember, what did we say? What were our 3 rules of quality assurance? Know what you're doing, know what you should be doing, and know how to measure the difference, right? That was what we said. But when we're talking about testing, the 3 sort of things that you should be thinking about is to know for sure what to test, to know how to test, and to know when we have enough tests. So while we had those 3 quality rules, we also have 3 testing rules. So when I say know for sure what to test, that means we need an easy, systematic way to create tests, such as go to every if statement, create an input that causes it to be true and causes it to be false. We also need an easy, systematic way to run the tests, right? Such as creating a script or using JUnit or something like that. And we need an easy and systematic way to decide when we're done, when we have enough tests. And that would be when I know that there's a test case for every if statement that evaluates it to true, and a test case for every if statement that evaluates the false. That's my criteria for being done. So this is an example of systematic. And this is what we mean by systematic testing. And when we go through in detail in the next few lectures, black box and white box methods, that's one of the things I'll be stressing is why is this systematic versus not systematic. We'll look at a couple of non-systematic methods as well, and we'll be able to see clearly what the difference is. So, in summary, the things you should take away from this lecture is that testing is not a one-time task. Testing is a continuous process. Tests are used throughout the life cycle. They don't just stop when you've done development. They don't just, end when you deploy the software. The other thing that you need to understand about testing is that effective testing is not just something you can wing. You can't just try it and use a bunch of inputs that you think make sense and that'll be good enough. Really effective testing requires careful engineering. And it is very similar, and it is in some ways a parallel to how we develop software. If we need a process for software, we need a process for testing. And I did highlight that a little bit about the keys to that process being that you need to have an overall testing strategy, which drives a test plan for your project, which informs how you design your test cases and the procedure under which you run all your tests, evaluate the outputs, and determine the results. The last thing I want to mention, we actually talked about this up front, is that there are 2 main classes of systematic test methods that we can leverage and use in our testing when we're doing test case design specifically, and those are black box and white box methods. Black box methods are the methods that assume the software we don't know how it's implemented, or that maybe the software isn't even implemented yet. They rely on the specification, the requirements doc, to design the test cases. White box methods, on the other hand, they actually rely on knowledge about the source code and insights about how it's implemented to help design test cases. So they're 2 different approaches. As I mentioned before, they're complementary because they can find different types of bugs, such as errors of omission and errors of commission. And we'll be spending a couple of lectures talking about some very specific methods over the next week. or so leading into our reading week break. So that concludes today's lecture, and next time we'll be talking specifically about black box methods, including things like input, output, and specification or requirements, specification coverage.